This is the third practical application of Bê-a-Bá da Eletrônica magazine number 3. Circuit analysis as seen by ET, the energy source. Until now, we have seen the battery as the energy source. Imagine that the particles are piled up inside the negative compartment of the battery, one pushing the other wanting to get out, but there's no way. On the other side of the battery at the positive pole, a very comfortable space without any particles, eager to receive visits from them. This discomfort generates a tension between each one, which is the battery's voltage value. In the void on the positive side, there is a tension as it needs to be filled if we imagine that voids could not exist in nature. When making the connection between the poles, the particles will be pushed to fill the void, catching the first particles that are on the external wire. If the wire is thin, fewer particles pass through, and it takes longer for the battery to run out. If it's thick, it takes less time. This will happen until the number of particles on one side is equal to that on the other side. That is, when there is a balance. You observe that the current goes directly in one direction. That's why it's called direct current. When electric current circulates, a magnetic field is generated. Conversely, a magnet produces electric current. So, a motor rotating a set of magnets next to coils will produce electric current, and that's how we have energy at home. The word coil is generally used for a cylinder on which something is rolled. A coil of paper, cloth, thread. In our case, the coil is made of thread wire. The magnet has one side full of particles and the other almost free of particles, looking like a battery. When the magnet starts to approach the coil, if it is the side of the magnet full of particles, those on the coil begin to move away, and when it reaches the side of the magnet with almost no particles, those on the coil will accumulate very close to that side. In your home at first, a current full of particles negative will appear in the socket on the phase wire, and in the second moment an almost total absence of particles positive. Unlike continuous current, the particles come and go alternately, which is why it is called alternating current. The speed at which this exchange occurs is related to the speed at which the turbines at the power stations. In the USA, this alternation occurs 60 times in 1 second. That is, when the second's hand moves from 1 second to another, the current has went and came back 60 times. This is called frequency, and the unit used is the Hertz, named after the German physicist Heinrich Rudolf Hertz. The transformer. The transformer we will use has the function of inducing current in another circuit. It doesn't transform anything. The current that circulates with a certain voltage on one side of it, the primary, induces a certain current with a certain voltage on the other side, the secondary, depending on the winding used on each side. The primary and secondary do not communicate directly, only by magnetic induction generated when current flows through a wire. If you use the same type of wire and roll up an amount of wire for the primary and, on top of that, the same amount of wire for the secondary, you will have the same voltage induced in the secondary without the wires touching. But what if the amount of wire was reduced in the secondary? The voltage would reduce because there were fewer particles, but they would have greater agility. This would maintain the same power. In the transformer, the power in the primary must be the same as in the secondary, being ideal. So if the voltage is reduced, the current increases. P equals V times I. Each reduction or increase of thread is counted by turns. And there is a relationship between turns and voltage. Suppose you roll up a wire and it made 100 turns to form the primary that will be connected to the 120-volt socket. But you only need 60 volts. Then you use the following relationship. EP over ES equals VP over versus, where E is the number of turns, V is the voltage, P is primary and S is secondary. In the case mentioned, you would have to roll up. 100 over ES equals 120 over 60. Therefore, ES equals 100 over 2 is equal to 50 turns on the secondary. Our transformer has an iron core that provides greater induction. It has the following format and is made by winding the secondary over the primary on the inside of the iron core. The primary can have 2 or 3 wires. One for 0 volt, one for 120V and one for 220V. Let's use the first 2. In the secondary, 3 wires may also appear. The middle one would be 0V and the extreme ones would be the desired output voltage. The one I'm going to use is 12V. So I'm going to use the extremes as positive and the center will be the negative. If I use both extremes without using the central one, I would have 24V. There are other settings that may appear when purchasing a transformer. Look. We already have 6 volts to power our circuits, in my case 12 V. But they are on alternating current. We need to convert them to continuous. This is the role of the diode. Its symbol is an arrow indicating the movement of the current in the conventional direction, from positive to negative. And how it works. When the top diode is pulling current, the point becomes positive and the charges go to the central terminal, as the bottom diode does not allow current in that direction. When the current reverses, the top diode does not allow this, but the bottom one does, and the charge leaves through the middle terminal. Thus, there will always be current in the negative and positive like a battery. The problem is that it will be a battery with voltage rising and falling, due to the variation in alternating current. What to do? We had to fill it with current when it was falling. This is the role of the capacitor. It will receive charge when it is in one hand, and when it is in the opposite direction, it will release its charge to fill the void that was forming. The LED is the indicator that there is energy available at the source. To calculate the resistor for the LED, I would take V equals 17. I don't know why the voltage of 14 jumps to 17 when placing the capacitor, minus VB equals 2.5, the minimum necessary for the white LED that would be left after passing through the resistor, equals R, which we want to know, times 0.02 amperes, the maximum current supported by the LED. This would give 14.5 equals R times 0.02. So R equals 14.5 over 0.02 is equal to 725 ohms. Then I round up to the highest value. In this case, I would use 1K. 14.5 is equal to 1000 times I equals 0.0145 amperes or 14.5 milliamperes, which would not burn the LED. I took the measurements with the multimeter and obtained LED equals 2.82 volts, R equals 13.50 volts, and current equals 13.60 milliamperes, considering the 17 volts. So, 13.50 plus 2.82 equals 16.32 V, almost 17. And 0.0136 amperes times 1000 ohms equals 13.6 V. Tension gave 13.50 on the resistor. If you use the scheme given by Professor Bêda Marques, it will work perfectly. But I thought about transforming this mini font into a multi-font. But what do you mean, ET? There is an IC from the 78XX family that stabilizes the voltage at a certain value. The 7805 maintains the voltage at 5 volts. But certain parameters need to be followed. Above, the format of the casings and the limits table obtained from the website. In this multi-source, I use the 12V and 400 mA transformer. So we can have outputs from 5 to 15 volts. Why? Because our VE min and max, minimum and maximum input voltage, is 17 V. The maximum amperage is max, will not exceed 400 milliamperes. And the output voltages will be 5, 6, 8, 9, 10, 12 and 15 volts. In fact, I intend to only use voltages of 5, 6, 9 and 12 volts. This source is more focused on simple experiences that don't require much. On the same Nova Electronica website, it is recommended.
Required if the regulator is located at a distance greater than 8 cm from the filter, capacitor. Recommended in circuits that need to limit high-frequency noise.
In our case, we can use it without these capacitors. Furthermore, it warns.
Reverse voltage occurs in inductive loads such as motors, relays, transformers and electromagnets, and in order to protect against this problem, the voltage regulator circuit must include an additional diode, the so-called flyback diode, which must be placed between the input and the output. This diode can be a common rectifier diode, such as the 1N400X diodes.
Some ways are suggested on how to produce different output voltages. Look.
The example below uses a 1N914 diode to reduce the voltage. Take into account that each diode has a different drop voltage. In the case of the 1N914, which is a fast diode, the voltage generates around 0.7 volts.
I only understand that you should only use the multi-source for one circuit at a time. 2 diodes 1N4004 or higher. 1 white LED. 1 kiloohm by a quarter watt resistor. 1000 microfarads by 16 V electrolytic capacitor. 1 transformer from 110 220 volts to 6 volts by 250 milliamperes. One simple switch. One pigtail with male outlet.